tumble turns, dives, glides and stroke technique. Every aspect of movement is crucial for elite swimmers. For their coaches, training athletes for a sport where most of the activity takes place in water is obviously a challenge. However, a pioneering wireless tracking system developed by UK researchers has been helping some of Team GB's swimmers prepare for London 2012. It brings existing sensing and motion tracking technologies together into one system. Crucially, the researchers have also developed revolutionary technology that enables data to be transmitted wirelessly through water. The research has been taking place at Loughborough University, led by Paul Conway, Professor of Manufacturing Processes.
This came about really from a challenge from British Swimming, who had tried a number of times in the past to understand a bit more about how their swimmers performed and how they might measure how they perform. Because the swimming pool is quite a challenging environment because there's lots of water. The human body is mostly water, so it makes tracking things wirelessly very, very difficult. And doing things like measuring in real time, things like speed, number of strokes they're taking, how they move in the water and how they turn or how they start, is very difficult because there's a lot of water and it's a noisy environment in terms of the signal noise and the amount of interference you have.
Professor Mike Kane is director of Loughborough's world-leading Sports Technology Institute. Along with Paul Conway, he explained more about the new system.
It's a small box of electronics that's worn on the small of the back that sends wireless signals that are picked up by a laptop receiver on the pool side. And that laptop then displays the various measures that are of interest to the athlete and the coach.
And then at each end of the pool we have a pressure mat essentially stuck to the wall. It's a very thin pressure mat, which is like a large area. I think when you touch it you can measure pressure, essentially force. Also we've got some underwater high-speed video cameras, and also on the swimmer we have some LED markers which are quite unique, which are waterproof markers they wear on their hip.
The idea was that we would utilise technology, things like accelerometers, gyroscopes, motion tracking techniques that we'd either directly developed ourselves within the research group, or we were taking those technologies as they were emerging elsewhere and integrating them into a package that would support the swimmers and their coaches. Effectively, an accelerometer allows you to derive speed, velocity. Of course, you can also derive acceleration, so the rate of change in velocity, and that can be just as interesting. A gyroscope is important because the swimmer turns at the end of each length, and so you're able to characterize the position through the tumble turn, and you can then analyze the technique. We start to look at the biomechanics, or the kinematics, the human motion relative to their position in 3D space, and it's important to understand the orientation of the athlete so that you can make some meaningful analysis from those data.
Innovative projects underway at the Institute's research labs range from the development of new materials for sports footwear to tailor-made handle grips for rackets. Paul and Mike say a significant aspect of this research has been developing a way of transmitting wireless signals underwater.
Wireless technologies are part of our everyday life now, but you'll appreciate that the vast majority of transmissions are through air. There are very, very few everyday applications that require transmission through water. And so it's not surprising that the transmission of wireless information through water has received less attention. And that really meant that all of the everyday commercially available protocols just didn't work in that environment.
I can disclose that we've optimised the frequencies of our transmission, the antenna design on the swimmer and also on the base station on the side of the pool, the arrangement of the equipment on the swimmer and beside the pool, also the software, putting intelligence in it so it knows what's happening and it can interpret if a signal drops out, what to do and how you can account for that. Building redundancy as well, so we can still get the data if we lose it for a few seconds. And putting that together with other things around the pool, such as video and force sensors and starting blocks and pressure pads at each end of the pool for measuring the turn, and putting that all together into one system, integrated system, is a unique thing, which you can actually watch it on video, high-speed video, and also see what's happening with an inertial sensor that's showing in real time. So each frame of the video is synchronized with what's happening on all the other sensors. And that's probably the key step, is bringing it all together, integrating the various sensor modes.
So we were having to genuinely invent new ways to transmit data that would be successful whilst in the pool environment. I can't describe exactly how we have done that because it's subject to a patent. It is an inventive step and it is one that has commercial value. But hopefully you get a sense of perhaps if you think about water as a medium and air as a medium, they're so different that you need a radically different approach to the same problem.
The new system enables coaches to give much quicker feedback to the swimmers.
They will see simultaneously on the computer screen, they see the video as well as the data that's coming off the node synchronized. They'll see also, if there's a turn, they'll see the data we're getting from the pressure map presented in a way that's understandable. We've got a nice colour map of, you can see when the feet touch the wall, how hard they touch the wall, how long they're on the wall. In terms of the time, some of them bend their legs a bit longer, so they're pushing a bit longer on the wall. They'll see also some of the measurements we get from the node that we're on the back. We can pick up stroke rate, the velocity, how quickly they turn, how quickly they tumble. And they get that almost real time. They can watch it real time and then it throws up the data.
Beyond swimming and London 2012, the system is already being looked at by industry to track components in factories, for instance, where there are wet and noisy environments. The project is supported by the Engineering and Physical Sciences Research Council. Other partners are British Swimming, UK Sport, Imperial College London and Queen Mary, University of London.